Hi guys, so this is a new video on Math SL differentiation. In this video I shall be continuing with optimization problems and I shall solve the two questions on the screen. I shall begin with question 1 short. So question 1 came in paper 1 May 2016, time zone 2, question 9. Kindly take a minute, attempt to solve, and the answer shall follow through shortly. So we are told that the container has a height x, a width x, and a length y. And as you can see, I've duplicated the given variables in all the corresponding sides. So if this guy is x, then obviously this guy right there is x, and as well as this guy and this guy. So these are all going to be x. And similarly, since this is y, hence this is y, and this is y, and this is y. Also, since this right there is x, hence, since this right there is x, hence this is x, and this is x. So I've just labeled all the sides according to x and y, and it's obvious, the shorter sides are x and the longer sides are y. Now, we are given that the volume is 36 meters cubed, and the area, the outside surface area of the container is given by A of x. We want to show that A of x is given by this expression, 108 over x plus 2x squared. So whenever you are given something about surface area, always imagine yourself to be painting the box. So if I'm going to paint the box, which sides shall I paint? I shall paint this face right there. I shall paint this face right there, the front face, the back face, the bottom face, and possibly the top face, depending on whether this is an open or closed container. In this problem, we are given that the container is open. So you have to check whether the box is an open box or a closed box to see whether you're going to paint 5 faces or 6 faces. Right, left, front, back, and bottom, and possibly top, depending on whether it's open or closed. So in this case, we shall not paint the top. So what we need to do now is evaluate the area of the left face, the right face, the bottom face, the front face, and the back face. And this is what we shall do. So the area of the front and back faces is given by xy, and let's see why this is the case. So the area of the front face, the one right there, the one facing us, is given by multiplying this x by this y. Similarly, the face at the back is given by multiplying this y right there by this x right there. If I multiply these two sides, I get the area of the back face. Now, if I want to get the area of the side faces, the right face and the left face, I simply need to multiply x by x, because these are squares. Same thing for the other side. I shall multiply x by x. So the area of right and left faces is going to be x squared. The area of the front and back faces is going to be xy. The area of the bottom face is obtained by multiplying this x by this y to give us the area of the floor of the box. And this is also xy. So to repeat, the right and the left faces are x squared. The front, the back, and the bottom are xy. Hence, the surface area shall be given by 2 of these, front and back, 1 of these only because the top is not included, and 2 of these. So we have 2xy plus 1xy plus 2x squared, or 3xy plus 2x squared. Now let's check how to get the volume, or what we know about the volume. We are given that the volume is 36 meters cubed and the volume of a cuboid is given by width times length times height. So x times y times the height, which is also x, so x squared y equals to 36 because this is the given volume. And we want to find a dash of x. So let's try that. Excuse me, we are still trying to find a of x in terms of x only, not in terms of x and y. Hence, we are going to use the volume in order to remove the y. So in this expression for the surface area, we have both x and y. We want to find the surface area in terms of x only, so we're going to use the volume to achieve that. So the volume, as we said, is given by x squared y, and x squared y shall equal 36. Hence, y shall equal 36 over x squared. Now, I'm going to take this obtained value of y and plug it into the equation for the surface area to get the expression that they want for the area. So a equals 3x times 36 over x squared plus 2x squared, which gives me 108 over x plus 2x squared. And this is the expression that they wanted us to show in the question. This matches the expression that they wanted us to derive in question A. So in question B, I'm required to find a dash of x, which is simply found by differentiating this expression right there. And notice that even if you do not manage to solve question A, you can still continue the rest of the problem normally, because A was a show that question. So you just use this value for the expression of a of x and you get a dash and you solve the rest of the question. Anyway, so how do we get a dash? Simply by differentiating the blue expression right there to obtain this red expression, and you can simplify to get negative 108x to the power of negative 2 plus 4x, which if we wanted to look a bit better, we can rewrite as 4x minus 108 over x squared. Excuse me, this is not a of x, this is a dash of x. In question C, we are required to find the height of the container or the value of x that shall make the surface area minimum. This is found by setting a dash of x to 0 and solving. So I shall set this green expression to 0, do some algebra and solve. This gives me that x equals 3, or the height is 3 meters. In question D, I'm told that Fred paints the outside of the container. A tin of paint covers a surface area of 10 meters squared and costs $20. Find the total cost of the tins needed to paint the container. So first I need to get the number of tins that I shall use to paint the container. If one tin covers 10 meters squared, how many tins do I need? In order to find that, I first need to find the surface area when x equals 3, because we obtained that a height of 3 meters minimizes the area. So this minimum area shall be 54 meters squared, which I obtained by substituting 3 into the expression for a of x. Now this area requires 6 tins of paint, since one tin covers 10 meters squared, so I'm going to need at least 6 tins. 5 tins will not suffice, and since one tin costs $20, hence the total cost shall be 6 times 20 equals $120. So this concludes the question. Pause to write this down. I shall begin the next question shortly. So the second question that we shall tackle in this video came in paper 1, May 2018, time zone 2, question 9. Kindly take a minute to pause and attempt to solve, and the answer shall follow through shortly. So we are given that this is a closed cylindrical can, and remember we said that closed and open matters when we are talking about surface area. We are given that the radius is r, the height is h, and the volume is 20 pi. Express h in terms of r. Let's see how to do that. So the volume of any object is given by the base area multiplied by the height. So since this is a circular cylinder, the area of the base is pi r squared multiplied by the height, which is h. And pi r squared times h equals 20 pi, because this is the given value of the volume in the problem. So since pi r squared h equals 20 pi, hence we can remove pi from both sides. R squared h becomes equal to 20. Next we can rewrite this in terms of h. So h equals 20 over r squared. So moving on to B. Show that C equals 20 pi r squared plus 320 pi over r, given that the material of the base and top of the can costs 10 cents per centimeter squared, and the material for the curved side costs 8 cents per centimeter squared. So we want to show that the total cost is given by this expression. So if we are talking about top, bottom, and curved sides, then we are talking about the surface area. This is the material that covers the entire thing. So if you're talking about covering or coating or something of the sort, then we are talking about the surface area. So we need to get the surface area of this shape. So we are going to look at the surface area because we are coating or covering or painting a can, and we need to make sure to check whether it is open or closed to determine whether we shall include or exclude the top. In this question we are told it's a closed can. Now the surface area of a cylinder is equal to the curved area plus the top plus the bottom. The curved area of a cylinder is given by 2 pi r h. So the cost of the curved area shall be 8 multiplied by the area. But first I shall remove this h and rewrite it in terms of r. So instead of h, I'm going to write 20 over r squared, which we obtained in A. So now I have an expression for the area in terms of r. This is 40 pi over r. I'm going to multiply it by 8 because this is the cost of painting the curved side as given in the problem. So 8 times the area gives me 320 pi over r cents. So this is the cost of the curved area. Next, I want to get the cost of the top and the bottom. So the area of the top is pi r squared. Obviously, this is a circle. Hence, the cost is 10 pi r squared because we were given in the problem that the cost is 10 cents per centimeter squared. Similarly, the area of the bottom is the same as the area of the top. Hence, the cost will be the same. Also, 10 pi r squared. So the total cost shall be 10 pi r squared plus 10 pi r squared plus 320 pi over r, which gives us 320 pi over r plus 20 pi r squared. This is the total cost of the entire shape. You will notice that the cost that we have deduced or derived is the same as the cost given in the problem. In question C, we are told that there is a minimum value for C, and we want to find this minimum value in terms of pi, and there are 9 marks allotted to this question. So even if you don't do B, the majority of marks on this question are obtained by solving C, and C depends on the show that equation given in B. So you can use this equation regardless of whether or not you've managed to derive it in order to solve question C. So we want the minimum value of C, so of course we need to differentiate C. This is the expression for C that we have derived and that is available in the question. I've rewritten it here in a differentiation friendly form. I've taken the R in the denominator to the numerator. I have not differentiated yet. This red expression is the derivative of the purple expression. This should be simple for you to figure out. Next, I shall set to 0 because I want the minimum cost, so C dash is going to be 0. I shall set this red expression to 0, hence obtaining the blue equation right there. I shall simplify and solve in order to find the value of R, which we shall obtain to be 2 because R cubed is 8. So if R cubed is 8, hence R equals 2. If we want the minimum cost, then we need to plug the value of R into the expression of the cost. So since R equals 2, we shall plug 2 instead of R into this expression. This gives us 320 pi over 2 plus 20 pi times 2 squared, which gives us 240 pi. You cannot use decimals or approximations. So even if you have arrived at 240 pi and then you have decided to write a decimal approximation, you shall lose marks because you were asked in the question to give the cost in terms of pi. So take a minute to look at the answer again and write it down if you will. This concludes our second video. I hope you have found it useful.